In this video, we'll be looking at how we can approximate a car's speed at a specific moment in time. Before we do, remember that if a car is traveling at a constant speed of 25 miles per hour, this means that changes in the car's distance, measured in miles, are 25 times as large as corresponding changes in time, measured in hours. Since speed is measured by comparing changes in distance and corresponding changes in time, you cannot measure a car's speed at a moment in time, which is why this quantity needs to be approximated. Imagine you are in a car merging onto a highway. At the 3-second mark, you look at your GPS app and it shows you your speed at that point in time. But GPS technology only measures your position, not your speed. So how does it figure out your speed? It measures the position of the car periodically, maybe once every second, and uses this information to estimate the speed. In previous videos, we looked at how this worked when you were driving at a constant speed. But what if a car is merging onto a highway, so its speed is changing? In this video, we'll look at how GPS approximates the speed of the car 3 seconds after you start to merge onto the highway. We're going to consider this car merging onto the highway. We'll use the picture of the car to represent the position of the car, and the distance from the picture starting point will represent the distance the car has traveled. Watch the car moving along the road and see what you notice about the motion of the car. There are several measurable attributes of the car's motion we might be interested in. One of them is the number of seconds elapsed since the car began merging onto the highway. I'll show the car's motion again and use the length of a red bar to represent this elapsed time. Another measurable attribute of the car's motion is the distance it has traveled since it began to merge onto the highway. I'll show the car's motion again, this time adding a blue arrow to illustrate the distance the car has traveled. As you watch, think about how the length of the blue arrow, the amount of distance the car has traveled, is growing in comparison to the length of the red rectangle, the amount of time it has been traveling. We want to know how fast the car is moving at exactly 3 seconds after it began to merge onto the highway. To compare how the amount of distance traveled and the amount of elapsed time were growing, we can measure each of these quantities. I'll show how the amount of elapsed time increases again and mark off 1-second intervals to measure it. So the car traveled for 5 1-second intervals after it began to merge onto the highway. Next, I'll measure the amount of distance the car has traveled since it began to merge onto the highway. This time, I'll use arrows to show the amount of distance the car travels in each 1-second time interval. Each time interval has an amount of change in time, in this case, 1 second. Also, each distance interval has an amount of change in distance. In this case, all of the distance intervals have different sizes. Now, let's think about how these time intervals compare to their corresponding distance intervals. These black lines indicate how each distance interval corresponds to a time interval. So, for each successive 1-second time interval, the size of each distance interval increases. Another way to say this is for any fixed amount of change in time, the corresponding changes in distance are increasing. And this is what it means for the car's speed to increase. Let's return to the question I asked at the beginning of the video. How does the GPS figure out the speed of the car 3 seconds after it began to merge onto the highway? The general method is to use average speed over an interval of time to approximate the instantaneous speed at 3 seconds. To start, we can find the car's average speed over the interval right before the 3-second mark. Using this interval, we can find the average speed immediately before the 3-second mark as 3.87 meters per 1 second. This speed, 3.87 meters per second, is an approximation of the speed at the 3-second mark. Then we can also find the average speed right after the 3-second mark. Using this interval, we can find the average speed immediately after the 3-second mark as 8.34 meters per second. Since the car is speeding up, the speed of the car right at 3 seconds is greater than its speed at any moment before 3 seconds. So the speed at 3 seconds must be greater than the average speed over any interval of time before the 3-second mark. This means that the first average speed is an underestimate of the instantaneous speed at 3 seconds. By the same reasoning, the car's average speed after the 3-second mark is larger than the speed right at the 3-second mark. So, the second average speed is an overestimate of the instantaneous speed at 3 seconds. And this tells us that the car's speed right at the 3-second mark is some value between 3.87 meters per second and 8.34 meters per second. If we subtract these two approximations, we can measure the accuracy of our approximation. Here, we know that we have approximated the instantaneous speed of the car's trip at 3 seconds to within 4.47 meters per second of its actual value.